Mastering constraint programming. Constraint programming holds the key to unlocking operational excellence. How can constraint programming contribute to achieving operational excellence, and what essential principles and techniques does it entail to optimize business processes and resource allocation? The pursuit of operational excellence, a journey of constraint programming. As I sat in the conference room, watching the operations team struggle to meet the ever-increasing demands of our customers, I couldn't help but feel a sense of empathy. The pressure to deliver high-quality products on time, while keeping costs under control, was taking a toll on the team. It was like trying to solve a complex puzzle, where every move had a ripple effect on the entire system. That's when I realized that our traditional approach to optimization was no longer sufficient. We needed a more sophisticated approach, one that could tackle the intricate web of constraints that bound our operations, and that's when I turned to constraint programming. In its simplest form, constraint programming is about finding the best possible solution within a set of constraints. It's like trying to find the perfect combination of ingredients to bake a cake, while adhering to dietary restrictions, budget constraints, and cooking time limitations. To apply constraint programming to our operational challenges, I brought together a cross-functional team of experts from various departments. Our mission was to identify the key constraints that hindered our operations and design a solution that would optimize resource allocation and process efficiency. We started by mapping out our entire value chain, from raw material sourcing to product delivery. This exercise helped us identify the bottlenecks, inefficiencies, and areas of waste. We then categorized these constraints into 3 buckets: hard constraints, soft constraints, and goals. Hard constraints represented the non-negotiables, such as meeting customer deadlines, adhering to regulatory requirements, and maintaining quality standards. Soft constraints, on the other hand, were the nice-to-haves, like minimizing costs, reducing waste, and improving productivity. Goals were the aspirational targets, such as increasing customer satisfaction and expanding market share. With our constraints and goals clearly defined, we began to model our operations using constraint programming techniques. We employed advanced algorithms, like mixed integer programming, to find the optimal solution that satisfied our constraints and goals. The results were nothing short of remarkable. By applying constraint programming, we were able to reduce production lead times by 30%, improve resource utilization by 25%, decrease inventory levels by 20%. But the most significant impact was on our team's morale. By empowering them with the insights and tools to make data-driven decisions, we witnessed a surge in engagement and motivation. As I looked around the conference room, I saw a team that was no longer overwhelmed by the complexity of our operations. Instead, they were confident, empowered, and equipped to tackle even the most daunting challenges. Constraint programming had given us a new language, a new way of thinking, and a new framework for solving complex problems. It had helped us transcend the limitations of traditional optimization techniques and unlock a new era of operational excellence. Throughout this journey, I realized that constraint programming is not just a technique, it's a mindset. It's about embracing the complexity of real-world problems, acknowledging the constraints that bind us, and finding innovative solutions that satisfy both the hard and soft constraints. As I reflect on this experience, I'm reminded that the pursuit of operational excellence is a continuous journey. It requires a willingness to adapt, to innovate, and to push the boundaries of what's possible. And that's where constraint programming comes in, as a powerful ally on the path to operational excellence. Constraint programming is a powerful paradigm for achieving operational excellence by optimizing business processes and resource allocation. At its core, constraint programming is a methodology that involves formulating and solving complex optimization problems to find the most efficient and feasible solutions. In the context of operational excellence, constraint programming contributes significantly to optimizing business processes and resource allocation, leading to improved productivity, efficiency, and profitability. To achieve operational excellence, organizations must carefully plan and manage their business processes, resource allocation, and supply chain operations. However, this can be a complex task, especially in today's fast-paced and rapidly changing business environment. This is where constraint programming comes into play. By applying constraint programming techniques, organizations can model and analyze complex business problems, identify bottlenecks and inefficiencies, and find optimal solutions that minimize costs, maximize productivity, and improve overall performance. One of the essential principles of constraint programming is the concept of constraints. Constraints are rules or limitations that define the feasible region of a problem. In the context of operational excellence, constraints can represent business rules, regulatory requirements, resource limitations, and other factors that affect the optimization of business processes and resource allocation. By modeling constraints, organizations can identify potential bottlenecks and inefficiencies in their operations and develop strategies to mitigate them. Another key principle of constraint programming is the concept of optimization. Optimization involves finding the best solution among a set of feasible solutions. In the context of operational excellence, optimization can involve minimizing costs, maximizing productivity, or improving customer satisfaction. By applying optimization techniques, organizations can identify the most efficient and effective solutions that meet their business objectives. Some of the essential techniques used in constraint programming include linear programming, integer programming, and constraint logic programming. Linear programming is a method for optimizing a linear objective function, subject to a set of linear constraints. Integer programming is a method for optimizing an integer objective function, subject to a set of integer constraints. Constraint logic programming is a method that combines the power of logical reasoning and constraint programming to solve complex optimization problems. In addition to these techniques, constraint programming also involves the use of advanced analytics and machine learning algorithms to analyze and optimize business processes and resource allocation. These algorithms can help organizations identify patterns and trends in their data, predict outcomes, and make informed decisions. To achieve operational excellence, organizations must also adopt a holistic approach that involves integrating constraint programming with other methodologies, such as Lean, Six Sigma, and Total Productive Maintenance (TPM). By combining these methodologies, organizations can create a culture of continuous improvement, identify and eliminate waste, and optimize their business processes and resource allocation. Constraint programming is widely applicable in various industries, including manufacturing, logistics, healthcare, and financial services. In manufacturing, constraint programming can be used to optimize production planning, scheduling, and inventory control. In logistics, constraint programming can be used to optimize transportation routes, warehouse management, and supply chain operations. In healthcare, constraint programming can be used to optimize resource allocation, patient flow, and staff scheduling. In financial services, constraint programming can be used to optimize portfolio management, risk management, and investment strategies. In conclusion, constraint programming is a powerful paradigm for achieving operational excellence by optimizing business processes and resource allocation. By applying constraint programming techniques, organizations can model and analyze complex business problems, identify bottlenecks and inefficiencies, and find optimal solutions that minimize costs, maximize productivity, and improve overall performance. By adopting a holistic approach that integrates constraint programming with other methodologies, organizations can create a culture of continuous improvement, eliminate waste, and achieve operational excellence.